What's good, y'all? Today I have another good friend on here. I've known him for several years. This guy is about his business. This guy really is out there doing some magnificent work. I've watched him engage kids and allow them to learn more about the STEAM industry, especially engineering. And I want you today to go ahead and lock in because he's going to give you a lot of information that's going to potentially help you figure out what your next moves need to be in order to potentially move into the industry in which he's in. Now, obviously, I gave you a hint today, which I try not to do, which is he's obviously in the industry of engineering. And with that, let's get to the first important question, which allows him to be here and for me to even interview him. So, first off, do you like your job?
So, very first question, do I like my job? The answer is a resounding yes. I love my job. I can't think of any other career fields where I'm literally every single day I'm inventing new technology. And not only am I inventing like new technology, you're making things that are going to have an impact. Whether it's someone who is driving home and everyone's had that problem where it's like they start their car and their car doesn't work. There's problems right there, but I'm the engineer. I'm sitting there working in the back saying, hey, when that person turns that key, that thing's going to work. Or someone they're flying across. We've even had in this pandemic, people are flying home, they're trying to like go see their family, they know that they're ill, they're sick, and when they get on that airplane, their expectation is that that plane's going to take off and it's going to land safely. So it's a real impact, and that's what engineering is all about. Is we solve the toughest problems which have critical needs for the people around us.
This is big facts. This is big facts. In fact, you all tend to figure out how to make the impossible possible, which is the coolest thing. I mean, it's an engineer who, frankly, at the end of the day, made it possible for a object that's weighs tons to be in the air going and flying from one continent to the next, defying gravity, which absolutely still to this day doesn't make sense beyond the fact that you know something. And shout out to you for knowing it so I can get to that continent. But with that, because you said some trigger words that got me excited, the child in me, because I've always wanted to be an inventor. So we're going to touch on that at some point, but we're not going to do that immediately. Next question is, what was the first profession that what was the first profession that you wanted to have, or at least that you remember having as a youth? Doesn't matter if it's something ridiculous or not.
I mean, if I really think back to like when I was like a little kid, so I grew up, I'm in a military family. My dad was in the Air Force and we lived in Oklahoma City. I was born there, did my elementary school out there. And really, when I think back to like the environment that I was in growing up, it's kind of strange because I was always an artist. I was always someone who just I like to draw things. I always like to like make things. Star Wars, that was always like a really big inspiration for me. And so a lot of times I was thinking about getting into like almost like yeah, I was always thinking like getting into like computer animation as the beginning. Just really just get into like designing like things that animations for like video games, for movies. Really just getting to that artistic side of things. And it wasn't actually until a friend of mine who was in there, he was like, hey, like I see you're designing things, but you're not really so much into like, the look and the aesthetic. You're actually thinking more about like how does it work? How does this thing function? That's actually what an engineer does. And I just kind of put two and two together. It's like, he's right. Like, because what inspired me more when I was that little kid drawing those little things, I was more intrigued by like, okay, this one image fits together, and this is like a part of an even larger thing. Like I was drawing spaceships, I was drawing cars, I was literally drawing buildings. Like I was always intrigued by like, here's the design, and here's how it all fits together elegantly. And that was kind of like the start, really.
And correct me if I'm wrong, now you're in a position to draw it and then bring it into a 3D setting in which now you can physically put it in the palm of your hand or on the whole desk and be like, yeah, I did that right there. And bring out the child in you in a whole different level that you probably, well, you might have dreamed about it because as kids, we had imaginations that didn't have great limits, especially when we were watching Star Wars back then. That was my movie too. I definitely watched everything and I got to get caught up on The Mandalorian. um, Well, so is that the reason that you actually took on this profession? And we're gonna get to the actual
You know,
title.
I mean, it's a really good, it's a good segue because when you look at and we'll kind of get into this as we start talking about engineering. What I think makes my specific profession so unique is that I can create something and literally in the very next day or even in the next few hours, I can have whatever I've just envisioned and imagined right in the palm of my hand. And so that's a really powerful feeling, especially when you're a designer or you're an engineer or you're someone who is creating something, being able to get that feedback, that first little sample so quickly, it's so valuable. You know, we have to think that, you know, in 2020 with the technology that we have so many different capabilities from making new technologies, making new things that can really have a positive impact in people's lives. But we don't remember that back in like the 1980s, or even like we got to go back to like 1969 when we go back earlier and Kennedy's made that claim saying, hey, we're going to put a human being on the moon in less than like a 3 year, 5 year timeline. And everyone thought that's completely wild. But you got to think that like if it took you 3 to 5 years to design it, test it, and get it to work, I mean it's such a long time, especially in today's standards where we want things so quickly and instantly. And you know, with the technology that we have today, we can crunch that time period from what would take people back in the day writing things out by hand, being able to use like a slide rule. They didn't even have calculators back then. We can do that in a super compressed amount of time.
Yeah, man, that's crazy. I actually really remember when that aired live. To see Kennedy come in front of the audience like that, like me and my family, we just sat there and listened to it on the radio because, of course, we didn't have TVs back.
What in the world? What?
You said like at first, I'm like, my guy is talking as if he was present for this. I was like, let's relate. I mean, let's do this.
You know, it kind of shows how far we've gone. You know, I think if we think about like, I'm trying to think of what's a good example. I mean, even if you just look at like, when you look at like a lot of different industries, whether in, you know, in your field, like construction, you know, for example, when you're doing like commercial real estate, you know, if we look at like how long it would take to design a building, being able to do all the, you know, you got to do your structural analysis to make sure that it's safe, you know, and then you got to build out the skyscraper. I mean, back in the day, this would a typical production time for that could easily take like multiple years to handle a
Mm.
project to that scale. And with where we've come so far with new technologies and new computer simulations that we can do all this analysis up front, and I'm sure you've seen in your industry that entire time is like completely cut in half.
Yeah. All right, so let's get straight to it, man. Let's get straight to it. Go ahead and give your official job title,
Okay.
and what does it actually mean?
All right, so my job title, I am a design engineer. And so with that, as a design engineer, I am responsible for coming up with how do we take 3D printing technology and we develop use cases and applications that we can implement for our customers. So when I talk about like what's a use case for 3D printing, I always kind of think of it, it's like, you know, everyone has a piece of paper and everyone has a pen, but it takes someone who's creative to write a novel on that piece of paper. It takes someone who's a designer or creative to turn this blank piece of paper into like plans for making a brand new building or plans for designing a new automobile or a car. And that's pretty much the role that we're doing is we are the ones who are going to plan out and create the actual value that is going to be used for our customers. So when we think about something like 3D printing technology, there's infinite possibilities of what you can make with a 3D printer. You can make little plastic bobbleheads. You can make little fidget spinners. You know, and those are all cute little things that you can kind of show to like your friends and everything. But in the world where we work in, we're going to like, what's that next level? So
Mhm.
when we talk about 3D printing, we're not just talking about the small things. We're also talking about how do we take this technology and maybe someone who has health problems, how are we designing an implant for them? If you find if you get like, say, like, you have a broken hip or you have like a knee injury, a standard implant is just like essentially it's like a steel ball and a socket, and they just completely replace your joint, and that's not really comfortable, and it's just not the most ergonomic thing in the world. But we can actually now design it so we'll actually 3D scan your body, and we'll actually create something that's custom tailored for you. So not only is it going to fit you, it's going to match the way that your body moves, the way that you uniquely walk, and it's going to be completely custom tailored for you. So that's like the health example there as
So I
well.
have to hop in. I got to hop in right there on the 3D.
Okay.
I want you to keep going, breaking down exactly what your job looks like for people. But I hear you guys talk about 3D, you people. I don't want to say you guys because we're doing your work. So I've hear you engineers actually talk about 3D printing. And every time I hear it, all I can think is, so essentially you're making a mini statue and putting it there, because you all talk about it like this thing is actually moving and it's adjustable and can twist, and maybe it can. So that's what I'm personally asking you, because every time I hear 3D, I just think this concrete object is legit not going to move, not literally concrete, but this object made out of maybe plastic that has rigid lines on there because it's
Hmm.
printed off in a certain way.
So I mean, there's a lot of different objects that you can create with a 3D printer. I think probably one of the misconceptions is that a lot of people think that it's just like a plastic piece of plastic right here. But with the technologies that we're working with, we're actually making things out of metal. So we're talking like these are like fully high grade materials that you probably wouldn't find, like you wouldn't necessarily come across, like things like titanium, things like aluminum, things like really high grade steel alloys. So I mean, so if you talk about, well, what do you use metal, just the material metal for? There's a lot of different uses for it. We think about things like spark plugs in your car. That's like a mini explosion every single time, but we can actually 3D print parts that can actually be a fully functional spark plug in the uses. Even like most people don't realize this, but a lot of these airplanes that are flying around now, they've actually changed it so like the fuel injection nozzles are actually fully 3D printed parts. And again, these are like really complex design parts where where you've got different components in there, which you're mixing in fuel, you're mixing in air, you're at thousands and thousands of degrees in temperature, and it's fully functional. And it's all just based on the design and the shape and the geometry as well. But to your point, I mean, even if you go from like a static piece, there's actually newer technologies. So you can actually 3D print with living tissue. So people are 3D printing organs. So they're actually 3D. They're actually taking like samples of like pieces of cartilage, parts of like even like your heart, and they're able to actually regenerate an entire fully operable living organ. So they're doing this with livers right now.
They're
Like certain,
creating whole human organs.
yes, you can 3D print a bio human compatible organ. So this is like cutting edge work that's happening right now. And it's probably in the next couple of years, like you're actually going to see like more and more of 3D printed organs being like a common use, especially like when we have with today there is such a shortage of organs right now. And so like when you check your ID for like being like an organ donor, they're using your live organs, but there's a lot of cases where there just isn't much supply there. And so with this technology, you can actually take people's actual living tissue and you can actually use that to then create samples to then 3D print and create these organs here. So it's more. So I think when I say this point here is that we're not just creating a bunch of solid blocks. We're not just creating little Rubik's cubes, which you can kind of flip around. Like we're actually creating technologies that are, you create metal objects, which you can use in a lot of different areas. We're also creating objects that are using actual living tissue, so you can actually use these for organs and everything. And then we're also creating a lot of different objects that can be used in computers as well. So they're actually embedding like electronic materials inside of things. So even like in like computer chips and everything, they're actually able to 3D print conductive paths in them as well. So you actually have some electronic capabilities in them as well. So it's not it's so much broader than, here's my cute little block of just some plastic or metal. Like there's a lot of different things that people are doing with materials now.
Okay. Okay. Hmm. All right. So go ahead. Well, you know what? Before you go back,
I feel like I'm a college professor talking all of the engineering right here, but let me kind of bring this back a little bit.
yeah, we gonna get back. But I have so just one quick yes or no. Are you telling me that at some point there's gonna be a heart, or currently somebody has a 3D printed bio? What was the actual terminology?
Biocompatible.
Biocompatible heart.
It is on the way. Like
It's
there's
on
a
the way. Like
lot of
how many
a lot
decades?
of people. What was your question?
How many decades or how many years? Like what?
I mean, easily within like the next 5 to 10 years. Like that's not science fiction. Like there's already people across the world that are getting a lot of it's coming. It's in the development.
So we're getting close to immortality, is what you're telling me. Yeah, I did there. Exactly.
Yeah, but I mean that's a whole conversation in itself, right? Just on that topic right there. But I mean, the future. I think there's a book, especially for someone who's like wants to really dive into like new technology and engineering. There's a book called "The Future Is Faster Than You Think." It's written by Peter Diamandis and Stephen Kotler, and literally they go over everything that like you thought it was science fiction. You saw how like in the Avengers how they 3D printed that one of the superheroes there. It's not science fiction. It's actually coming to it's coming to reality sooner than people think about.
That's wild, man. That's freaking cool. Now go ahead. So a part of your job is working with 3D printing, is what I'm hearing. Generating 3D printed items. Can you tell more about what those items are, as well as what are the other responsibilities to your engineering position?
Yeah, so specifically in the scope of work that I work in as a design engineer, I am tasked with identifying what is a very practical and useful way of using 3D printing. And so part of what makes our company, the company that I work for, very unique is that we actually design and create the 3D printers and we sell the 3D printers. But then at the same time, we're also like the tech support, and we're the ones that are helping anyone who buys these 3D printers how to get the best use out of them. So we're in a unique position where we're actually developing a new 3D printer. It's a brand new technology that's going to make 3D printing faster than what people have traditionally seen with 3D printers. And it's also going to make it significantly cheaper than what most people have seen before. So for my specific job, I do a lot of consulting. So whether it's working with someone like the government, or if it's working with a very large defense contractor, or it's working with like a very large automotive company, as a design engineer, I'm actually working with their own designers. So they're the experts on whether it's designing a plane, designing a car, or if they need a certain amount of parts for their logistics plan. And then
So they break down. They have the actual layouts of their items.
They're the ones that they're going to be the experts on their product,
How it operates, the pieces, and things like that.
Exactly. And I'm the person who's translating it. So I'm the one who says, all right, I know that this is how you've designed it. This is how it works. This is what you need from it. This is how you want this product to function and to be successful. So how do I, using the technology that we're providing, how do we make sure that we can provide you something that's going to meet all of those needs for you there? And that kind of encompasses a lot of the challenges when we talk about manufacturing. And so, especially in the field of manufacturing, the expectation is that you're not going to create just one part, but the expectation is you're going to make thousands, and in some cases, millions of parts. And every single one of these little pieces that you're creating here has to be exactly the same. It has to It has to function the same way. It has to behave the same way. And if there's any defects or any problems that show up, you have to scrap all those parts. And so it's very important as a design engineer that we're also making sure that as we develop this part, we're also developing a production process for them as well. Because their expectation is that as soon as you flip the switch, this printer is just going to make the same thing every single time. And that's that in itself is it can be a challenging aspect to it as well, especially when you're creating new technology. Because we're at the same time we're also figuring out, okay, when this behaves on the printer, it doesn't work as correctly. Like I always kind of think of it like if anyone's ever used like a copier machine, like when you click a button and you say like I want like 1,000 copies of like my report or whatever it is, your homework for class or whatnot, you always expect that hey, the copier is just going to make the same thing every single time. But what's not necessarily appreciated is the months and the years that went into developing to make sure that that thing was going to work the same way every single time. So that's kind of where I'd say like 3D printing technology is today, where it's that we can make a few things very well, and in some cases we can make a lot of things very well, but we're still developing our expertise and getting the technology up to that point where that someone one day they can just click it and it's good every single time.
Okay. Okay. So tell me this then. Are you this because this is what the way I'm hearing what you're saying is you are the individual who actually makes the 3D printer. Like you're the person that's figuring out how this 3D printer is going to be created that's going to create what everyone else needs, your customers' needs are. So I don't know if this is how this works, but I'm going to be very, very, well, let's say tripod since we're doing
Yeah,
it. So if we're looking at a tripod, you're creating a 3D printer that creates every little part for a tripod and you're putting program, it sounds like you're having to address coding inside of this
yeah.
actual 3D printer. You're also having to figure out how the actual machine is physically going to be built and how it's going to be able to do the 3D printing in the process based off of how 3D printers were previously made, and you just continuously updating the one that you're working with for your customers' benefit. Is that accurate?
Yeah, that's a true statement, and I think it's also, but it's two sides to it, because not only are we, we're obviously going to optimize and we're going to make sure that this is a fine working machine, but we're also it would be a disservice on our part to not only let them use something that's kind of old, because this is a new technology. There's new ways to create things, and so with that we have new possibilities. So on top of that, we're also working with our customers to get them to think differently. So if we imagine that, like, if you're like and this is common in our company, when we work with these different industries, they've been probably doing their developing their products for the same way for the past 50 to 100 years. That's kind of pretty typical. It's kind of like here's a tried, tested, and proven way, and there's no real point to deviate from that. But the reason they didn't necessarily deviate from that was because they had the limitations from what was currently available. And so now that we have this new technology, we have new possibilities, completely new possibilities. So when we talk about things like we're 3D printing parts that people can use as implants, people are 3D printing these parts that we're going to put in these high combustion like environments, there's new possibilities to it. And also when we think about what are some new functions here, we can create different shapes that you just could not normally create with any other manufacturing process. And so
Example?
yeah. And so part of our work is the teaching as well. We also work with them to say, hey, like you've designed it this way, and that's probably what you thought it could be like for the rest of all time. But with this new technology, it can be something completely different. In fact, a very common way we kind of describe this is that say you have something that's really complex, like an automobile. There's a whole bunch of different parts, different pieces that go together everywhere. But if you can just simplify, even just like a small section of this vehicle, it saves you so much time. It saves you just a lot of planning, and it saves you just a lot when it comes to like actually implementing and the logistics of creating something. So I think what's probably the more powerful thing is that you can simplify what was previously a complex and disorderly object, which maybe may have had like 20 different pieces. You can now make all of those pieces as just one 3D printed part. So new possibilities. I'm talking like part of what makes my job so unique is that not only is you get to help other people see what's possible as well, and you get to help them think differently as well.
Okay, so can you, there might be proprietary information involved, so I'm trying to figure out how to ask this question. Answer the best way you can, I guess, is what
Okay.
I want you to do. So can you be specific, not literally saying what the actual item was, if unless you're allowed to. Can you be specific about a specific product that was presented for you and what the entire process looked like for you to actually follow through with making that thing become a real product for your customer?
Okay. So there was let's just say there was a very prominent automotive manufacturer. Like I don't need to name them, but when everyone ever thinks about like being like successful and like kind of like, man, you know, like that's the first thing I'm gonna buy. That's the caliber of like an automotive manufacturer that we're talking about. And they not only is this company very famous, but they're famous for a reason because they
You
know
don't
that
gotta give us a hint if you can't give us a hint. You can just keep going.
but I'm giving you some good stuff. So I mean, so they actually are probably one of the best Formula One race car teams in the world. That's how prominent this manufacturer is. And the challenge that they're facing is that, you know, especially in something like a Formula One, you're trying to go fast. You want to have the fastest car out there every single time. And one of the ways that you can make your car go faster is being able to conserve as much energy as possible. When we think about like when you have that exhaust on the end of your car right there, that's a lot of wasted energy, wasted combustion products in there and everything. But one of the things is that if you can recycle that energy more efficiently, you can go faster and you can completely like get a more you can get more output out of your vehicle. Especially like in a Formula One environment, it's all about who's the most efficient, who's the fastest on the track, and who's going to have the most reliable and consistent operating vehicle. So one of our tasks was they presented us with a couple of different ideas, and they said, well, you know, we thought here's an idea of like, you know, what we think we can do with this technology. You know, we have all these different shapes and ideas. And one of the ideas that we presented was that, well, you've done this way for the past 10, 20 years, but with this new 3D printing technology, we can actually create some very unique shapes here that were never even possible with what was currently available. And now that you're creating these different shapes right here, you can actually construct this critical piece of your engine, which I can't really go into too much detail there, but it's a very critical piece of the engine that you can actually, instead of just taking all this energy and it just kind of dissipates, goes out your exhaust, we can actually recover it in a really novel and clever way that no one's ever really done before. And so we had actually came up with this entire new design, and it completely blew their mind. They were just like, wow, we've never even thought this was something possible, just with the technology capability that we've had before. And they were able to actually put this on the race car, and I'll pretty much say that they did very well in the Formula One season this year.
Okay, and what was I'm trying
I
to,
know.
man. Like I have questions, but I'm trying my best not to get you in trouble because you seem to keep trying to give out hints. Because at this point, I have a really, really good idea of what team this is because I do watch. I don't watch Formula One, but I've watched their documentaries enough that I pay
Yeah.
enough attention to what's going on because it's pretty cool to when you see behind the scenes of something. So I'm trying to not give away too much just because I have a feeling at this point who you're talking about. And I feel like others do too. So not to do this, but what are the shapes that you keep mentioning?
Yeah, so
Like you keep mentioning, not, and you don't have to talk about
so
for that.
I would the
What are you
best
that weren't previously able to be made?
yeah, so the best analogy that I can give to kind of describe like what's complex. So like if you were to like so if we think about like most objects that we interact with. We think about our chairs, we think about a couch, like some forks and everything. Everything's rectangular and it's like very straight lines, like, even like cabinets and everything in our house. Like everything's a straight line or it's like a circle or it's like, it's got like a little curve to it, and it's the reason it's that way is because it's very cheap to do that with today's technology. It's pretty much like a very straight, very simple process. When we talk about 3D printing, we're talking about I can create something that can perfectly match like, the curve of like my hand, all the different wrinkles, all the different rivets on it. Like that's the level of detail. Like even like the knuckles and everything, we're capturing that level of detail with the state of the technology. Even if you want to talk about like how fine of detail we're talking about, if you ever on like Google, if you just type in like what does the inside of a bone look like, for example, the human body, the bones that we have, they're actually everyone kind of I think a common misconception is that the bone in our body is a solid block of material. But that's not the case because if it was a solid block of material, we would not be running around, jumping around, doing whatever. So the inside of our body, of the bone itself, it's actually hollow. So it's actually like a bunch of really small little grids of material that's put together. And it's really, this is like probably like, I would almost say it's like the size of the human hair. Like it's really, really small. It's really fine precision detail. And that's the level of just how much detail we can capture with these shapes right here. We're creating things that are on the orders of, people think like a millimeter small, but we're talking like microns. Like that's like, way, way smaller than a millimeter. So it's really high detail and we can literally create shapes that mimic nature. Like that's probably like the biggest thing when we talk to people about this. Like, nature is the perfect designer. Nature's already come up with a lot of different things. We talk about like the curvature of like a bird's wing. That's actually how airplanes fly. It's that curvature, the camber of the actual of the wings, and that creates the lift effect right there. Um, we can capture all of this intricate detail in one single object. So it's
Say that a little
literally.
bit louder one more time. Say that last part a little bit louder because I think that your audio was a little bit soft right there.
Oh, let me see if the audio is cutting in a little bit better here. But we can capture the detail and resolution of pretty much anything you can imagine. Like everything from like we're capturing the details of the human body all the way to capturing the details of how nature has designed itself.
Hmm. Okay. This is
So
so intriguing. So what you're telling me is when it comes time that I have the real type of money I expect that I will have at some point, I can make my house not have the normal columns. I can have like these big grand oak tree like
yeah,
pillars going up opposed to the traditional pillars. I can have a tree trunk essentially be the pillars in my home because of your technology.
yeah, that actually is a yeah. So there actually is 3D printed houses that are coming out now.
Hmm.
So there's actually a company that's actually going around and they're 3D printing like all the different walls for houses. There's even like machines that are 3D printing bricks as well. So I mean, to your point, like if you wanted to design a house that looked almost like a jungle and like the columns were shaped like tree trunks, it's definitely actually it's 100% possible with today's technology. You don't even got to wait for it. It's already happening.
Is it expensive? Because it sounds expensive.
Well, it's like all new technologies. Things come down. I always think like you and I probably remember this. Like back when like big screen TVs came out, those were like, gosh, it was almost like $2,000, $3,000 for like a TV. It was crazy, and it's so hard to think like, wow, people were really balling like that, thinking that that was like a good thing. And nowadays, it's like you can go out and get like a 4K television, 42 inch, and it's only like $300 or so dollars. Like it's a 10x reduction in costs. And so that's kind of where 3D printing is right now, where it's like for a big company where I work at, it is a very expensive process and expensive technology, but as it becomes more into the norm, as people start getting more experience and we start building up that expertise, the cost of being able to access the technology will lower as well.
Okay. Okay. Huh. Man, I'm gonna be honest with you. You're making me more and more jealous. Every time I talk to people, you all bring out the child in me who was so interested in so many things. And frankly, I don't know if this is dating myself or allowing myself to be judged. I don't care. But Magic School Bus as a child
Hmm.
made me want to be an inventor with all of my heart. Still to this day, when I wrote down my 100 things I want to achieve in life and like the milestones I want to do, being an inventor is on there. On my vision board for years has been be an inventor. Like that is so freaking cool. I used to try to, I remember Miss Frizzle, I want to say she had a robot that they created on the episode, and I called myself doing it with some stuff in my room. Obviously, it wasn't a robot, it was essentially just a glorified shrine. And thank God I was I think so. I almost did something very stupid. Kids, do not do this at home because I could have not felt my toes the rest of my life had I done
Oh
it.
goodness.
Yeah, 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 yeah. So I want to say it was either on one of the Magic School Bus episodes or something else. You know how those glide, you know, you can go parachute, you can do a parachute, um, or you can do the gliders. I can't think of what those actual technical terms are, but
Okay.
yeah, I had a kite. See where this is going? And I also had a banister that was essentially 2 stories high. And I looked off that banister like, I think I could fly off this thing.
Ooh.
And thank God, as a 5-year-old, 6-year-old kid, I was like, you know what? I'm gonna jump on my bed and just see what's the best way to do it. Mind you, my whole body, it's a kite. It's a normal kite. It's
Yeah.
nothing spectacular.
It's,
So it's the skinny little plastic. I don't know how they built now, but it's the skinny little plastic, a little bit thicker than a couple straws inside, wrapped around each other. And I tried to put my body in it. It popped, of course.
oh.
And then the kite, and I tried to put it back together. I was like, all right, I'm just gonna hold it over my head and jump. And I jumped, and thank God, I think the
Oh.
wing broke or something like that in the process. I was salty because I couldn't use the kite anymore. But in hindsight, if that wing didn't break, I probably would have broke some
Ooh.
stuff in my own
Ugh.
body because I was not thinking. Well, I was thinking like a kid. There was no limits in my mind at that point, and you still get to be that kid, which is freaking sweet. You gave us some of the origin of what sparked this interest. So go ahead and lay out the actual journey, the official path in which you did and what another person can do in order to get to your current position. And that does include feeling free with adding any feedback like I did this that was non-traditional. And so somebody could do this to make it an easier path than what I went through.
Yeah. So I mean,
And
I
start
would
from
say
college.
like
Start from college unless there's something important needs to be heard from high school.
there's a lot of different paths right now. Like I think probably when I started out, the concept of like working concept of what's a 3D printer, that was only like a few people in like my college even knew what 3D printing was. Nowadays, like I do a lot of work with them, working with kids. I'm doing mentorship. I'm doing a lot of technology showcases so that the youth can get access to the technology as well. So, and even at the library, especially like if someone they can't afford a 3D printer, they just want to like at least test it. You can actually go to the Cincinnati Public Library and they have 3D printers there available for people to use. So there's a lot of different community resources available today. And even if like you don't want to use the library, there's websites. Shapeways.com is a good website that people can go to, and you can actually upload like a 3D model, and they'll actually print it and ship it directly to your front door. But so those are things like today that people can use. When I talk about the journey, you know, when I started out, this was way back in like probably 2000, yeah, 2010. Oh wow, yeah, 2010, 2011, and it just so happened, I was just a young, involved, sophomore in college, and really just trying to like find like what's some opportunities to get involved in. And I had actually talked to a professor like my freshman year, and yeah, it didn't quite go the way. It's kind of like you see this person, you're like, man, it's going to be great. We're going to like work together. And this professor I talked to just was not having it at all. Just was not, for whatever reason, they were just kind of in their own different world. And so kind of pushed me off the path. I'm like, all right, I got to find something to get involved in.
Were you looking for
And
him to be like a mentor, and he just kind of shut you?
yeah, that's the I think that's a good way to describe it. I was kind of looking for like a mentor. Again, coming from that, like I like to design things. I like to make computer models, and yeah, this person was like the computer modeling guru of my university, and he just, for whatever reason, just was not interested in what I had to say. So kind of back to the drawing board, and they actually had an event going on, and the professors were coming out there saying, "Hey, we've got research, undergraduate research, and if you want to learn more about the research opportunities, this is an opportunity for me as a professor to share it with you, and if you as a student want to get involved, you can, connect with me." And so I was there, and it just so happens that the person who did end up becoming my mentor, who did end up becoming my advisor, he was there, and he said, and the very first thing he came out there and he said, "Who here has ever had Invisalign?" I'm like, all right, what's so unique about Invisalign? He's like, well, hey, you probably don't realize it, but every single Invisalign aligner that's created is all made using 3D printing. They take a 3D scan of your mouth, and that's custom fit to how your teeth and how your jaw structure is, and they 3D print every single mold, and they use that to create your Invisalign trays. And it was just like, wow, like I've never even connected the dots on that before. So it was really intriguing just seeing that there. And he was just like, well, hey, and if you think about 3D printing, what would normally take like a company like an Apple, for example, if they want to make like the iPod, or like, yeah, at the time like the iPhone, normally they go through like a 7 to 10 year development cycle of just completely taking the design, crafting it. But they started using 3D printing, making all of these different prototypes, and they were able to do it in like 1 to 2 years. And so I was really intrigued just seeing them. I'm like, wow, like there's a lot going on here. And I was really drawn, and we talked about this earlier. I was drawn by just the just this aspect of, wow, something that I've designed up here, I've imagined it, and you can literally have it in your hand the very next day. It's such a powerful thing, especially as a creator, as a designer, as an engineer. Like you just have it right in your hand. It's like getting like a Lego set, and the entire Lego set is built like the very next day. Like it was so surreal. And so yeah, so I and it was just a pretty much a match right there. So I approached him, and I kind of was the very, I took some initiative on my part there, because I kind of approached him and said, hey, like I don't really know much about 3D printing, but I do know a lot about 3D modeling. I know how to design and make the things, and I would like to volunteer in your research lab and do some undergraduate research. And yeah, sure enough, he took a shot. I had no background. I did not have any expertise. All I had was I just had the drive and the enthusiasm and the motivation, and yeah, he took a shot. And a lot of times it's just putting yourself in that opportunity, just putting yourself in that space so that you can actually like progress and receive that opportunity. That's probably just, I would say, is probably the entire, is just showing up is probably 90% of the entire outcome. It's not about necessarily being the best or being the most highest ranking or standing out. Just putting yourself in the space can give you so many opportunities there.
So
So
tell me this, because you said he just took a chance. We talk a lot about mentorship in these videos because well, we talk a lot about internships. We talk a lot about mentorship in these interviews. And what I want to do is have you break down exactly what that mentorship looked like. And then let's definitely get back to your path as well as what degrees you had slash major you had. But what you since you mentioned mentor and that he was that, what did that actually look like and what does that mean? Like how did he help you get to the phase of life that you're in now?
So there's a lot of different ways of when we talk about mentorship. You can have certainly you can have like like someone who's trying to help you achieve your goals. So that's someone like in a university setting that's like an academic mentor, someone who's kind of helping you along with your classes and everything, who's kind of guiding you along. Certainly, even like when we go out into like the professional world, you can even have mentors that are kind of guiding you along your professional journey. You know, kind of coaching you on like here's some different skills that you may need to work on to progress through your career. And so when I look back to the gentleman that I worked with back at my university, um, when I can describe his mentorship, it was a mix of a lot of things because it was a mix of the academic aspect of it. Certainly, the research, here's this technology, here's what it's going to go through as well. But also, I think he also helped me along when it came to really building myself personally as well. Being like a high achiever in like a university environment. One of the things that I really appreciated about him was like his emotional intelligence. He was able to kind of like really dive in and see like, hey, like you have so much going on and you have so much potential right here, but you know having your priorities and like having the bigger picture, that's a really important thing. Don't and it really helped me stay balanced. I one of the things that I experienced very early on was burnout, where I
Mm.
was like trying to do so many different things at once, and it just completely unraveled pretty dramatic. In a lot of different ways, and it impacted my how I was doing in my classes, how I was pretty much spending my time with all the different work that I have, and it was. I still remember we had. I remember coming back. It was like I had like a it was the end of the year and I had to present the research that we were working on. And I remember just coming in there and I was just exhausted, completely just exhausted, starting to study for these engineering exams. Haven't seen my friends in probably like a whole month, just all about the books and everything. And and I'm going in there thinking, all right, and anyone who's been to college kind of knows, like you go to the office trying to talk to the professor, trying to haggle with them, saying, hey, I'm late, but can we work something out? And I go in there and I don't even go through the spiel. I'm just completely exhausted. And he said, Michael is gonna be okay. And it brought a lot of relief to me as well. And we had a conversation, and I can appreciate that he not only didn't just assess me for the academic aspects, but he also saw the potential in me, and he helped nurture me along that path. And having that awareness when I was in such a difficult situation to, be a guide in that moment, it was really powerful.
Yeah, I can see
And
that.
so to kind of like finish off the story there, so he ended up, yeah, so he was not only my academic advisor, kind of just like a personal advisor when I went through school as well. But he also ended up writing my letters of recommendation for grad school as well. So absolutely just a stand-up individual as well. And certainly when I see him on LinkedIn, I try and give him a little shout out here and there and plug in his piece because he was a really big influence on my professional journey and where I'm even at today.
Mhm. So, what was your major and your degree?
Yeah, so my major was mechanical engineering. So I got a bachelor's degree at Virginia Tech, and then I went to Penn State University and I got a master's degree in mechanical engineering as well. And so all of them were kind of intertwined. Where the first, when I was in Virginia, my undergraduate, it was kind of doing the research, learning about 3D printers, learning about how does these things operate, and he kind of coached me along the way and said, "Hey, I see that you're really interested in this work, and there's this really great program up at Penn State University." And it just so happens that this professor at Penn State University was my former roommate back when I was in grad school. So if this is a place you want to go to, I can write a letter of recommendation. And sure enough, he plugged me in, made the connection, and I met my then second advisor at Penn State University, and it was just a perfect match. Just so I say that to kind of talk about, when we talk about how you're going to get into 3D printing, certainly getting involved, if you can just use whatever's in front of you, whether you're at a community college or you're at a university or even if you're in high school, getting involved with some level of a 3D printing project, just take that initiative, even if you're like creating something simple for yourself that you want to challenge yourself as an engineer, just you want to show that you can be an inventor as well. That initiative is very key as well. But then additionally as well, I think also, building relationships. I was really fortunate that I was able to build a relationship with this advisor, my mentor over time, and then being able to then leverage his network as well to then go to the opportunities that I had as well. And then I think lastly, just being vocal about it. When I ended up pursuing my job right here, I went to a whole bunch of different career fairs. I was in grad school at Penn State, Penn State's located in the geographic center of the state of Pennsylvania, so there's not really much out there. Philadelphia is like a 4-hour drive. Pittsburgh is like another 3-hour drive. New York City is like another 6-hour drive. So you could certainly drive to get to these places, but you're not like out there every single day necessarily near where all the opportunities are. So I was pretty much busting my tail. I was at every single career fair. I even got involved in a lot of different conferences. I went to conferences in DC. I even went to a conference in Kansas City, and I was very
names of them. Do you remember any of the names of these conferences?
Yeah. Well? So the conference. So a good one for your users, especially like anyone who wants to get involved in the technology-based field or engineering. The National Society of Black Engineers is one of the best organizations to get involved in, not only from just career and professional advancement, but just the community of people that you're going to be around out there. Like you're not going to be the only person, like, especially if you go to any of these predominantly white institutions, as we typically call like some of these universities that you go to. When you're at a National Society of Black Engineers conference, you are surrounded amongst family. Yeah. And that in itself is powerful as well, because when you're amongst the family, they look out for you.
I can only imagine attending. I mean, so I attended HWCU, and having attended a HWCU, I'll definitely have to say that I can see where it's so important as an engineer being in a building where the walls are filled with only faces that reflect that it's a HWCU, and no one in there really looks like you. And if there's maybe a face like yours that shows up around 89, 91 or something like that, if you're lucky. And I can see how having an organization filled with brilliant minds like yourself, it helps you to be reminded like, hey, I'm not alone, as well as, man, I can be a human here opposed to be an individual in a space that has to constantly prove that I deserve to be here, opposed to me being here just like you're here, and we're here for the exact same reason, and you're not having to prove that why you're here, but I do because of any odd reason. And so for that reason, I can definitely see the value of a person who attends a HWCU and needs that. Because I mean, having attended one, I absolutely know that when I went to classes, I mean, I remember one of my professors in grad school, he asked a question, and it was a sociology master's. So this is why they would ask a question like this. He was trying to make a point. He was like, how many times when you walk on campus, and he said this to everyone, do you think about your race? Like, do you do this every single day? And of course, only the Black people raise their hands. And then dialogue happened, because it was like, yeah, because when you're a Black person and you attend an HWCU, chances are no one is going to not realize that you're present, unless they have their back turned to you. And once they turn around, they're going to know you're present. While if you're not black or any other person of color, then there's a high chance that when you walk on campus, you're the majority. You're just another student, and it allows you to have the freedom to just think peacefully with clear thoughts only about the actual work, opposed to, do I have to prove myself because I'm present as myself? Which is absolutely ridiculous out loud. But I hear you. So you said Nesby. How many, like, just so people can have a good understanding of how many career fairs you went to, like, because you're talking about the resiliency that it took for you to have this position, as well as talking about what you did in college and how there was a guy who kind of turned you down, but you're like, yeah, whatever, I'm gonna keep going. And you that's called being tenacious, and that's extremely important. And for people to know that people like you who are successful, it didn't just happen. So how many career fairs did you have to go to in order to actually establish yourself in the industry
I mean,
and find a job? And find a job.
to be fair, I wouldn't really put the emphasis on the number of career fairs because it's going to vary from people. Like
Mhm.
I remember the very first career fair I went to as like a freshman in college, and it's just it's something that as you get more experience, it's going to come more naturally. Whereas I had peers, so I went there and there was probably like I'd say like 110 companies, and I probably talked to about like probably like 30 of them, and pretty much got shut down by all 30 of them. No interviews, no nothing. And then I think I went to my second career fair, and I actually did actually have a little bit of success at that second career fair. But everything when it comes to like getting into like a career fair environment and you're really fighting to like make stand out amongst like thousands of other people, I think the very best thing that anyone can do is really just kind of like I alluded to earlier, take initiative. you know when people talk about like you're at a career fair and they say that you don't have the experience, you have to make the experience for yourself to stand out. And you have that's where you have to take the initiative on your part to really get involved and really showcase your skill set. So in my case, doing that undergraduate research and getting involved with here, I've worked with this professor, and we actually have some 3D printers on campus. And through this work, I was able to actually understand and figure out what are some common problems with the 3D printing technology. And not only that, we ended up writing an entire research publication, and this got sent to like it was presented at a conference, and now it's been published in an academic journal. Like that was my specific case right there to get involved. But there's lots of different things, and even if it's not just if we're talking 3D printing, there's so many ways that as an engineering student you can get involved. Like if you're someone who's like computers, if you're like a coder and likes to program, being able to show that like, well, I didn't get this job, but I was part of this hackers group on campus, and we ended up creating this little mobile app on our phone that was able to show us when anyone was on campus and they were like a DoorDash driver. I'm kind of spitballing here, but getting involved and showcasing your skills is incredibly valuable.
Mhm.
There's different clubs that you can join. There's different you can actually do unpaid internships as well. So you can do like an externship, which is kind of like a very short 2 week, 3 week period where you kind of get to shadow somebody as well. That's showing initiative as well. There's summer research opportunities as well. Another sidebar, I was able to actually go to a university up in New Jersey doing research on nuclear reactors.
At what
And
point?
hmm?
At what point is this? Is this college, grad school?
Yeah, we're still in college here. We're still in college here, but a lot of these research opportunities you can get them through university, or you can actually get them through there's government research labs. So if think about like the most common ones like Oak Ridge National Lab, like that's a really big institution that the government's funding to do research. And a lot of these different labs they'll bring on interns as well. And it tends to be a much more of a, in my opinion, I think it's a much easier route to get into because again, it's just taking the initiative. You know, if you can really just articulate, put your skill set out there, and you can clearly articulate why you think this would be a good opportunity that you want to get involved in. I think that's like an untapped opportunity that I think gets overlooked a lot of times when people think about the career fairs and the big fancy Apples and Amazons. Like, there's a lot of opportunity just working in like a research lab, and oftentimes you can get paid to do the research there as well.
Hmm.
So
So
that's another untapped opportunity.
yeah, I was gonna ask you about that because you didn't mention this. So we're in college. You're either in grad school or undergrad, and did you not receive any official co-op opportunities or internships? You didn't mention anything there, so I'm just curious. 'Cause I know at
Yeah.
UC, that's a
And
big
that and
deal.
so I was fortunate enough to actually have a few co-op and internship opportunities as well. So that's, I would definitely say that's for anyone who wants to get into engineering. That's the gold. That's the gold standard. But it is very very competitive.
And
And
how long were your co-ops?
so each co-op that I did, there were the first internship was for the summer duration, so that's about 3 months. But I did also do a full co-op, which a co-op is you have two internships kind of back to back. And so I had one where it was from the summertime and then it was all the way through the fall. So that was, so I did end up taking some time away from school to have that extended co-op experience as well.
How much were you getting paid? Because I know for a fact that they get paid good money when you are
So
engineer.
I will say that it's industry specific. So like when I was doing when I did the research for that government research lab I was working for in New Jersey, that was about I want to say I think that was like about a $7,000 to $9,000 internship opportunity there. So that, and that's over like 3 months right there. So that's, so even as like a college student, that's a pretty decent amount of money right there to work with.
Yeah.
Um, you know, I did a few different stints and a lot of different. I did kind of jump around, look at some different opportunities. I did work for a very, very large oil and gas company at one point, and this was back. If you remember, there was a time where the price of oil was like $140 a barrel. That I may be off right there, but I'll just say that I was making so much money as an intern, like it was
No, be specific, boy. I mean,
okay.
we're
All
not
right.
in your pockets right now because that was a younger version of you, but we talk real low.
All
And
right. I think
you
I
know
was
that.
making about when I was working for that oil and gas company. It was like I want to say it was like 3,000 a month. Like it was definitely like a lot of time. That's like a salary for like a lot of people. They make it like
Mhm.
3,000 a month there. So it was a very good salary as an intern there.
At what
Uh,
age and what year is this in college?
so I was a junior in college at this point here. So probably I was like, yeah, I was 21 at that point there.
Man, you were making more than I was for like my first 4 years of my profession.
And I'll make an asterisk because this was at a time when the oil and gas industry was booming. It was absolutely booming. So yeah, as an intern, it was like wow, like they had classes there saying, hey, you know, you guys are interns, but we want to talk to you about retirement planning. They were already teaching you about the Vanguard, teaching you about the IRA and the 401k. Like it was the game that they had was that you would actually take your intern money and you could actually put this away into the company 401k plan. But because you were essentially a temporary employee, you would have to get all that money out anyway because at the end of your internship. So you got the money back and you also got the match in the 401k plan as well. So that was like some game that they were giving out really early on. And it's just like, wow, like imagine if I did if for people who did that internship like 4 years in a row, like you could have made some serious money
Yep.
just doing that.
Yep.
But that's kind of the oil and gas industry as a whole. And I'm sure like it's certainly going through a challenge now with everything that's happening. So it varies. What I will say is like, you know, those other internships that I had working in those research labs and certainly I did do a couple of internships with the company I'm working with now, even though the pay was not like the pay was certainly, you know, within that like 7,000, 6,000 range. as to the best that I can remember there. So a little bit less, but I would say the work and the relationships, you kind of get different benefits depending on what you're seeking. Whether it's salaries, maybe the main thing that you care about, or maybe it's, you know, being in an environment where you're doing fulfilling work and you're building relationships with people that, you know, you're going to be, that you can see yourself potentially working with over the next couple of years.
Okay. Okay. So it sounds like you mentioned the fact that you took a little bit longer due to focusing a little bit more on your co-op. I know a lot of people, like my teammates, they actually did co-op, and it was included. I don't know if this is just a UC program type of situation, but it was a part of their academic process. So it counted for like their what they did at their job on their co-op counted towards their semester or maybe half of a semester or whatnot. I wasn't a co-op, so I don't know. I'm just wording it the way they was set up with at least the way I heard it. So I don't know if that was how your situation was. If it was, definitely speak on that briefly. And the other part is do me a favor and tell me what is the traditional amount of time it takes to graduate from undergrad and grad school to get to your profession.
So there, I would just say there is so many different, there's a lot of different paths. And one thing that I can appreciate about my college journey is that it's going to be your personal journey. So certainly like the ideal, and this is ideal because it really is like pretty ideal in a lot of ways. Ideally, you know, someone can get through like an engineering program in 4 years. And then what a lot of schools will do is they'll offer like a 1 year master's program where they'll take your senior classes and they'll count them as credit for graduate school. And all you have to do is just do like an additional year of coursework and you get a master's on top of that. So you could do that in 5 years. And there are people who do that, and you know, hats off to them. You know, that's kind of like, you know, that's kind of what worked out for them. That was the cards that they kind of had. And you know, certainly, you know, they work for it. You know, it's not an easy thing to do. So it's definitely a good achievement in itself. I definitely
Co-op?
probably hmm?
Did that include co-ops and internships in that fourth?
That probably included internships, but a co-op by its nature, it is going to take over time for a semester. So like when I did my co-op, it did push me back. And the challenge, especially for anyone who's kind of thinking about doing a co-op, is that you should always check to see like if you are going to take a co-op, is any classes that you're taking going to be impacted by that? So like in my program, it's like in order to graduate, you have to take in sequence a fall senior design project and then a spring senior design project. And you can't like mix and match. They have to be done in that sequence of you get there in the fall, you do the first segment, and then you do the second segment your senior year. And then oftentimes there's even classes, and this was another thing I came across where they had classes where they only teach this specific class during the fall, but they don't teach it during the springtime. Or they'll teach it during the springtime, but they don't teach it in the fall. So understanding the schedule is another element that I would kind of advise anyone to kind of look at when they want to take on a co-op as well, because like in my situation specifically, there was a couple classes that they only offered them during the fall period. So when I was gone during that fall semester, I ended up having to actually stick around a little later to come back and take that specific class in order to officially move on to my senior year. So it was a pretty involved process. You know, I was in school for, so with, I did about, yeah, every single year in school, I was either doing an internship or a co-op. I was about four, I want to say four internships with a co-op in there as well. So I was in, so my undergrad was about, it's about 5.5 years. So it was definitely like a mix of a lot of different things from the academics and the internships kind of moving the schedule around. And then grad school was about a 2 year period. And what's unique about grad school for someone who thinks about, you know, I've got this job, why should I go to grad school? If you're in like a technical field, like engineering, oftentimes you'll actually get paid to go to grad school. So I was, yeah, you know, it's a very, that's some game right there. So So I had applied for like three different universities. So I had applied to three different universities, and these are like the Georgia Techs, the Carnegie Mellons, like, and I got into all these schools, and these are really top-notch engineering programs. And every single letter said, "Congratulations, you've been accepted." And then it says, "All finances and tuition, you will be responsible for them." So it's just like, wow, like who in the world is going to pay for all of this? And then I got my letter from Penn State, and they said, "Well, hey, congratulations, you got admitted. And not only that, we want to offer you a research assistantship. So not only are we going to pay for all of your tuition, but we're going to give you a stipend so that you can just do research the entire time you're here studying for your master's." So
that's how they
definitely,
get you. That's how they get you. So,
that is true. I will speak on that a little bit more. It's a
because
feeder system as
yeah,
well.
and for clarity, if definitely correct me if I'm wrong, because what I'm hearing is a situation in which the average person doesn't know who actually created the iPhone. Like we always connect that to Steve Jobs and whatnot, but
Mhm.
if you watch the movie or listen to documentaries, he went into a room and said, "Hey, I want that and this. All right, this is what I want to happen. Figure it out."
Mhm.
I said, "Figure it out." I don't care if you haven't slept in 3 years. Figure it out. And essentially, because it's under the brand, they get the credit and make all the billions and billions and billions of dollars. And you got paid for your services, just like a collegiate athlete who worked for free. And yet at the
I
same
will,
time,
it translates over into the academic side as well. It is like, what makes grad school, it's a conflict because it's like essentially you're essentially, to be very frank, you're an underpaid employee because you already have the technical skills, you already have all the qualifications, and certainly if you add in the tuition plus the stipend, it actually does match like the typical entry level salary for how much money that is cumulatively actually being put up front. So it does actually capture a lot of the value there. But what I think is often overlooked is that as a grad student, you're kind of pursuing your research, but you're also pursuing a degree as well. And so as an academic institution, they do have a little bit of leverage over like if we don't see X amount of output from your research, you may or may not be able to receive your degree. So it's a very it's a relationship that you have to kind of navigate. I remember I came to Penn State, and there's a lot of things that can happen in like along the way. So like you get in, I got my master's degree, and they're paying for it, and I get a stipend. So you're kind of living large right there, and you can get very comfortable. You can get comfortable, and then they say, "Hey, like you really like this work. Why don't you stick around to do a PhD? It's only like another 3 more years. I mean, you've already shown that you've got the tenacity for it, and we'll give you like a little bit of a bump in the stipend here." And what often doesn't get talked about is that like that 2 to 3 year process can stretch out to like another 6 or 7 years. And that's not to knock anyone who's gotten a PhD. A PhD is a very powerful an achievement in itself. And I definitely commend all the people who've gotten the PhDs. But again, it's personally tailored, and it's got to. I think when you're pursuing that PhD, you're going to have your own personal motivations that are driving you for it. And all the political nonsense of like faculty advisors and maybe you have to stay a little bit longer, that's all going to be noise outside of if this is your passion, then I say completely go for it. But like any other industry, there's a lot that can happen. So like I certainly have had peers who they did take a little bit 6 to 7 years to finish their PhD program, but you know they are fulfilled. One of them is actually like a professor. This is someone who came from an HBCU. They came from Alcorn State. A lot of people from Penn State came from Alcorn, which is down in Mississippi. They came there, you know, did the PhD. They blocked out all of the noise. This was their passion, and now they're a professor at Princeton University. Black woman professor. teaching molecular biology at Princeton University. So I mean, if you got a vision, you got the tenacity. I say completely go for it. Don't let the distractions get to you, because this is your passion. And if you got a vision for yourself, I'd say go all the way.
Okay. So as we talk about you graduating from grad school, did you already have your job lined up when you got out? And what all positions have you held after you graduated? And I guess your travel
Yeah.
to
So
Cincinnati.
yeah, so I was doing all the kind of talking to people. I was talking to a lot of people that were in startups. I was talking to a lot of different companies. It was it's interesting to think of like how I kind of navigated the space. But what really got me to where I am today, I think it's a combination of things. I took initiative very long ago, being that sophomore, going to the career fair, and again, not having the experience, but I said, hey, you know, I got involved. Here's some work that I did on these little projects outside of my classes that showcase my engineering skills. I'm doing this research here. And, the company I'm working with, they took a shot and they offered me an internship. And that was kind of like the starting piece right there. And then they offered me a co-op from there as well. And then 2 years after that, I kind of said, well, I want to kind of search around, do some different things. So it's probably been like almost like a 4 year. I almost want to say like a three, probably, yeah, I'd probably say almost like a 3 year kind of ebb and flow between from my last contact point with them. But it was, I'm out there on my LinkedIn, and one of my former mentors from my internship, he had said, hey, I just came across your profile. I know we haven't talked in a couple of years and whatnot, but I just want to let you know we're actually creating this brand new business, and you have all these qualifications here. I think you'd be a great candidate for this role. And so it just kind of aligned right there from taking that initiative early on. It's like you don't really know the impact of a decision until like way down the line, and you realize like, wow, that was a really powerful set of choices I made back when I was only like 19, 20 years old, not realizing how well it positioned me to where I am today. And then just building relationships with people. This mentor that I had worked with, this is a separate mentor. He's one of my fraternity brothers who was looking out for me.
And your fraternity is
Alpha Phi Alpha Fraternity Incorporated. So certainly, if you got some viewers in there, shout out to the brothers there. But having those relationships and taking the initiative, I mean, it was kind of like it was just like perfect timing and just like the perfect setup there. And he was able to help get me through, get my foot in the door, and get my interview, and kind of the rest is history. And here I am. So I would kind of really preach to, especially anyone who's kind of viewing this, like, if you've got dreams and you got a vision, take initiative, get out there. Even if you have no idea what your skills are, what it is, just get out there, make that first step, and then tell people about your passion. When you tell people about your passion, they're going to also want to help you along your journey as well.
So give me this. How many jobs have you had after grad school? Like, we're not talking about co-ops and whatnot, like official positions outside of school. If possible, can you please, like, in order, say the actual titles?
This is the one and only job after grad school.
Oh, okay. So how long have you been
fresh out? I haven't hopped around. Certainly, I mean, there's definitely opportunities too, but this is kind of been like where I think it was best for me to start my career.
Mm-hmm. How long have you been in this role?
So I've been here for about 3 years now.
Okay.
So I've kind of gone from being the new person to now I'm a little bit more seasoned and kind of know how the business operates, where I fit in this business as a design engineer, and kind of like what's the next steps in my career.
So tell me this, and usually it's a little bit easier to ask this question because most people aren't still in their first role. Obviously, you've went through 3 years, and it sounds like there's been different advancements in your position. You just probably have the same title, just more responsibility over each year you've been at your company. Is that accurate?
Yeah, I would say what makes when you're like a design engineer, the way like engineering is you get more responsibilities. So kind of like when you start off, they kind of say, all right, we're gonna give you a little, we're gonna give you something here, and it's it's kind of if you mess up over here, it's okay. We'll kind of be able to work through it. And then as you progress through your career, they start giving you even more responsibility from, okay, this was a small piece to now this is, we're going to give you like a very critical part of this project here. And then as you keep moving forward, it's like, all right, you've gotten the project, but now we want you to we want you to manage how we execute on this contract here. This is a critical piece of, if we don't get this line item on the contract, nobody gets paid. Nobody gets paid. So you get even more. So that's a really big amount of responsibility. And then as you go up even farther, then you start getting into, you get two different choices there. You can kind of still be the technical expert. People lean on you to kind of make the technical decisions, to kind of really guide them, be the, here's what I think we should do, here's how we're going to solve this particular problem. Or you can kind of go into the route of, maybe your passion's not so much in the technology and the nuts and bolts and doing the math. Maybe your passion is, you like to organize the people. You like to be that person who is kind of coaching the team along. You're getting everyone together to work on a common goal, and you're just kind of, just being the director who's really out there just talking with people, figuring out what problems do they have, how, and empowering the team and each of the people to be successful. So that's kind of the two different routes there. From, you can be the technical know-how, or you can get into like more the management, the administrative side of things.
Okay. Well, do me a favor. Because I have to ask this question because I need people to know what they're getting themselves into. We love the passion, the excitement, and we always talk about how your passion can pay. So what's usually the entry level salary for a person coming out of grad school into a role like yours? What's the entry
So
level?
yeah, so if you're an entry level engineer, and this is across all types of engineering fields. So if you just came straight out of your undergraduate degree, entry level price, and I'll probably omit computer scientists because they definitely are like in their own separate category. As an entry level engineer, you're probably in that 60 to 70,000 range. That's kind of typical for where you're at. And by going to grad school can almost give you like a nearly $10,000 bump on your starting salary. So now you're instead of starting in that 60, 70, now you're talking like you could be easily in that 75 to 90 range just from the jump. So it definitely pays to go to grad school to get that little boost, because what happens is when you get into like a role, your salary is going to increase by different increments. Ideally, what should happen in a company is like your salary should increase incrementally every single year based on your, as you progress through the company, as you get into higher and higher roles. But each of those salary increases, they're going to be based on the number that you started at. So if you start off at a small number, that 10% bump on a small number and another 5% bump, it's a small increment, versus if you start off even larger, it's just going to compound even further.
Okay. Okay. And what is the trajectory for, what's the top position that one in your industry can have, and what is the potential salary range for that type of person? So we got you at 60, and I've moved throughout the ranks in this industry, in that profession of yours, and you can make what?
I'm trying to think on this because I would say that that is one thing that I do not know. And so I can only speculate on the price, but which I can say that, certainly getting into like the 100, the 150 range, that's definitely possible. I don't think that's like an outlandish statement to make. But certainly I think like if you're someone who wants to be like a director of engineering, or if you want to be like a chief engineer, I mean, that's you can definitely be in like the six-figure range with those type of roles there.
Okay.
But yeah, I don't have an exact number to kind of give you guys, but I know it's in that range there.
All right. All right. Well, I think you gave us a good feel for what's going on, and I'm surprised that you said one because I'm thinking we two, three, 400,000, probably close to a million, depending on the actual company you're working in,
Yeah,
and what.
certainly. I think if you go higher, like if you go even higher, like if you start getting into like maybe you're not the engineer, but maybe you're the person who's like coming up with the new product ideas.
Hmm.
Maybe you're the person who's like actually who's coming up with like here's new technology that we want to implement. I mean, you can definitely get into like very astronomical level private salary there.
Put a number on it.
Gosh, I cannot put a price on it because I'm not too familiar with the salaries. So
All right.
yeah,
Well, I'm gonna.
I don't want to leave you guys hanging, but I would just say like even just like as an entry level engineer, like I've got friends that are probably like same age as me, and they've been in the company a little bit longer. They're already like in the six-figure salary range. So it's if that's kind of like your aspirations, I mean, you can certainly get there pretty quickly without having to like wait like put in 20 or 10 years. Like you can get there and still be fairly young into your career.
Okay. Well, for everyone who's watching, I know you heard all of that, but here's the actual maximum salary one can have through my powers. I was able to generate this right here. Long story short, yes, that's what you can make. So I had to look it up, man. I'm not gonna just leave them hanging. We're gonna have to figure out what the cap is. So that's what that number is, and
Okay.
that's what it's gonna be. Well, definitely appreciate your time, bro, man. Do you have any final things you want to say to everybody before we head out?
Yeah, I would just kind of just say, like engineering, you know, whether it's engineering or maybe your viewers may not be as enthused about 3D printing, but whatever it is, whatever your passion is, I mean, I would just say just go at it at 100%. Find your passion, get out there, tell people about your passion, certainly, and really just be about it. Because the more that you are enthusiastic and you're knowledgeable and you have a clear interest in something, that's going to attract more and more
Okay. Well, you heard what he said. I'm going to add on by saying a lot of things he's brought to light are the fact that you need to be tenacious. You need to find a mentor. You need to find people who are doing the things that you desire to do. They're going to be able to guide you, help you. And if you caught what he said, he also spotlighted some of one of the things that we always talk about, which is not just what you know, not just who you know, but who knows you. And who knows you is the person that can call you because they've gotten to know your skill set as well as what your desires are. And they can call on you to fill a position that they know about that you may not have ever come into any awareness about had they not been present in a whole different city, maybe a whole different country, and called for you to step into that role. So make sure you're out there, you're building relationships. And even as an engineer, make sure that you have great social skills. My guy has been talking for over an hour now, and that's a perfect example of a person who's capitalizing on all of his assets, all of his skill sets, and is going to maximize the opportunity. And when you want to maximize an opportunity, you're ready for the opportunity. You're also present for the opportunity, as he mentioned already as well. So I appreciate you all for coming out and watching this. And to it is.
yeah, for sure. Appreciate it, Mario.
Oh, Jesus. Yeah, it's time to eat.